Good morning, welcome back to Question a Day. Today we'll be doing the July 15th question on integration. Now it's quite small here, so hopefully you can see okay. My camera seems to not want to focus on it, but that's okay. We have the equation y is equal to 3x to the 4 take 8x squared plus x to the power of 1/2 divided by x squared. Hopefully you can see that a little bit better. And we want to integrate this. Now, if you remember what integration means, in our kind of formula that we had, was it's if I have some expression x to the power of n, and I integrate it, now remember we write this kind of S sign, this S stands for sum up, that links to more the application of integration, but we know we have this kind of S sign, dx, when we put x to the power of n into that, it comes out as x to the power of n plus 1, all divided by n plus 1. And much like we did with differentiation yesterday, is we can apply this term by term. Now, unfortunately, y isn't in a state to integrate just yet. And our problem is this isn't just a chain of x to some powers. We've got this x squared that we're dividing by, and we need to fix this. So the way we do that is we simplify it using our exponent rules. So we can rewrite this as y, well, 3x to the 4 divided by x squared is going to be 3x squared. We've got minus 8x squared divided by x squared. Well, that's just going to be minus 8. And x to the power of 1/2, slightly trickier, but again we're just subtracting 2 off it. We get x to the negative 3 over 2. Now we have three things in the form xn, so we can now integrate this. So the integral of y, now we don't really have a symbol for this as such. Perhaps if this was the derivative of y, so we could slightly change the question a little bit. This could be dy by dx, so something like dy by dx is equal to 3x squared take 8 plus x to the minus 3 over 2. And we want to be obtaining y. We don't really have a symbol for just the integral of y on its own. Sometimes you can see it written as I for integral, but for now we're just going to integrate this. And we can just call it the integral of y. And that's going to be equal, this is where we make sure our notation is important. We're going to put the integral sign. I'm going to put what we're integrating inside of it. So this is the computation we're doing. It's really important for the layout of our answer. And we remember the dx at the end, because dx is telling us which variable we're looking at. So we're going to integrate this stuff with respect to x. Okay, and let's do that. So 3x squared will raise the power by 1. So this is going to become 3 times x to the power of 3. Now we need to divide it by that new power, that n plus 1. So we're going to divide that by 3. Minus 8. Okay, so 8 is a constant. Now we can use the same trick we had for differentiation, where we imagine there was an x to the 0 next to it. Or we could recall our fact that when we integrate a constant, that becomes 8 just multiplied by x. Or, if you want to think of it in a different way, x to the power of 1 divided by 1. We'll leave it as 8x for now. And we're going to add to this x to the minus 3 over 2 but we're going to integrate that. So we need to increase that power by 1. So that's going to become x to the power of negative 1 over 2. And we're going to divide it by negative 1 over 2. Simplify this thing up a little bit. We get x cubed minus 8x minus a half, not a half, divide by a half, that's 2. So minus 2x to the negative 1 over 2. And we're nearly done. And hopefully you've all been screaming at your screens that we've forgotten something. And that is that we need to add a constant of integration at the end, so this plus c. We should do this to each of our lines there. Once we've completed this integration, we should add the c. The reason for this is because we're undoing a derivative, and again recall from yesterday that the derivative of a constant is 0. Well, if we integrate this, we don't know if its original function has a constant term or not, because that would have been disappeared by the integration, by the differentiation, sorry. So that's why the c is important. And we'll just add c to our rule up here. And there we go. There you have it. That's a complete solution, not forgetting that plus c. It's really important that you don't forget that. That's all for today. I'll see you tomorrow.